So welcome to video 1-1 of the Mastering Hyper-V 2012 R2 book. And really in this video, I'm going through an overview and a history of exactly where we are with Hyper-V technologies today. So at a very high level, from the first version back in Windows Server 2008 through to where we are right now with Windows Server 2012 R2. I'm only going to use a single slide for this. So I think back to Windows Server 2008 and Hyper-V was added as a post-RTM update to give you the final version of Hyper-V. And it really consisted of a number of key features. Now firstly, it is a Type 1 hypervisor. So a Type 1 hypervisor means the hypervisor is running directly on the bare metal hardware. A Type 2 hypervisor is where the virtualization really sits on top of another operating system, which means that other operating system has to do certain duties around the processor and memory, known as ring compression, which really reduces the performance of virtual machines running on a Type 2 hypervisor. So you don't want your enterprise level hypervisors running your data center to be a Type 2. Now Hyper-V is a Type 1. Hyper-V as a hypervisor runs directly on the hardware, but it's easy to see why people sometimes get confused and think Hyper-V is a Type 2 because the order of actions is I install Windows Server on the hardware, I enable the Hyper-V role, so that makes me think Hyper-V actually sits on top of Windows Server. This isn't actually the case. What happens behind the scenes is when you enable the Hyper-V role, it actually makes a change to the boot configuration database. And that change is really, well, there's a number of changes, but the biggest one is this hypervisor launch type, and it's set to auto. So now what actually happens is when I launch this machine after Hyper-V's been installed, the first thing to load is the hypervisor. So Hyper-V is now running directly on the bare metal, directly talking to the processor and the memory, and then Windows Server effectively sits on top of Hyper-V. And Windows Server now acts as the management partition for the Hyper-V hypervisor. So we are a true Type 1 hypervisor. Now from a scalability perspective, the first version allowed 4 virtual CPUs. So this is 4 CPUs added to each virtual machine and up to 64 gigs of memory. Obviously the Hyper-V host could have more resource, but each VM could only have 4 virtual CPUs and 64 gig of memory assigned to it. Now you could actually maybe only have 2 processors in the box, but I could assign those 2 processors to 2, 4, 8 different virtual machines. They could share processor cores or logical processors within the operating system through the hypervisor. There was a 2 terabyte virtual hard disk format. So this is how storage to virtual machines was actually managed. I created a VHD file on my NTFS partition, and the guest operating system, the virtual machine, saw that as a real disk where it would install its operating system. Now in terms of mobility, there was a function called quick migration. And this was how you could move virtual machines between different nodes in a cluster. The challenge was this worked by effectively pausing the virtual machine, saving the state of the memory, the device, the processor to disk, moving that disk or LUN between different nodes in the cluster, reading in that memory, device, processor state, and then restarting the virtual machine. So it was quick, but generally not quick enough. And the virtual machine may have been unavailable for 30 seconds, 60 seconds, depends on the amount of memory. There was an iterative VSS backup capability. So this enabled me to do a backup of a virtual machine at the Hyper-V host level, and that backup request would actually be told to the virtual machine. So if I look at a virtual machine and I look at its settings, I'll see a number of integration services. One of these is backup. And what this enables me to do is when I take a VSS backup at the Hyper-V host, that VSS request is passed through to the virtual machine. Then the virtual machine can call all the VSS writers, for example, those from SQL, Exchange, or anyone else. That flushes all the application data to disk, quiesces any changes while the snapshot is taken, so I know I have an app consistent backup. So even though I'm taking this at the Hyper-V host level, I get that app consistent backup. So it's actually a great feature and it was there from 2008 version, and it's still there today, and there's actually some big improvements in 2012 R2. There was a snapshotting capability to take a point-in-time view of a virtual machine, and pass-through storage was possible. I could map, for example, a LUN from a SAN or some direct attached disk directly to a virtual machine. This isn't generally something you want to do because it does break some mobility and functionality, but because of that 2 terabyte VHD storage limit, sometimes it was necessary. So the clock rolls forward and we get to Windows Server 2008 R2. And this actually added a lot of new features, and primarily 2 of them really made Hyper-V a much more reasonable hypervisor that you could use in your enterprise. And this was the addition of a zero downtime migration capability, so live migration. And this really consisted of 2 technologies to enable me to move a VM with no downtime. So the first of these was live migration, and this was the capability to copy the memory of a virtual machine between 2 nodes in a cluster while the VM was still running. So it would copy the memory, and then once that had finished, the memory would have changed a little bit. Those dirty pages would be copied over again. This was an iterative process, each time the memory getting much, much smaller. And then once it was basically there, it could pause the VM for milliseconds, flip over any remaining memory, device, processor state, and then restart it on the other node. And all hypervisors work this way. But that millisecond pause is so small, there's no visible timeout, there's no TCP connection timeout, there's no interruption to the workloads going on in that virtual machine. But there's a second part required. So if we think back to quick migration, one of the things we had to do was dismount the LUN on the SAN and then mount it on the target node. The reason for this is NTFS is not a shared file system. It won't allow 2 boxes to talk to it at the same time. Well, that changed in 2008 R2. Cluster shared volumes was introduced, and this allows a single NTFS LUN, and I can have many of them, visible to all the nodes in a cluster at the same time. So for example, if I look at a cluster, I've got a cluster shared volume, and the way this actually is seen is this new cluster shared storage, and I see this volume 1. And this is consistent across every single node in the cluster. Every node in the cluster sees the same cluster storage namespace, the same content, and they can all read and write at exactly the same time. So it's this simultaneous read-write. It's still NTFS underneath, but there's some clever technology that handles the metadata changes, because it's metadata that generally causes problems. If I have 2 machines trying to update the metadata on a file at the same time, well, bad things can happen. Cluster shared volume solves that problem. So this now enables us to not have to move the volume when I move VMs between nodes in a cluster. It also removed the need to have lots and lots of small LUNs, one for each virtual machine. Now I could conceivably have a single LUN across a 16 node cluster with all of my VMs running across all the nodes in the cluster at the same time. So this now gives you a zero downtime migration. There was a processor compatibility mode added. So when I go and look at a virtual machine, I look at the settings. One of the challenges in the past was if you think about a cluster, I might add some new nodes to the cluster. It may have a slightly new generation version of the processor. So maybe some have an Intel Xeon, some have an i7, and that's a pretty drastic change, but it gives you an example. And that wouldn't typically work. When an operating system starts up, it scans the processor. It says, well, what instruction sets do you support? Now, if I started a VM on a Xeon, for example, and then I tried to live migrate it to another processor like an i7, well, they're going to have different instruction sets supported. Maybe it scanned an instruction set available on the Xeon that isn't available on the i7, so when it tried to use it, it would crash. That's a very bad thing. So Hyper-V would stop you performing a live migration to a virtual machine with a different version of the processor. Well, if I want to enable that, I can actually turn on this compatibility configuration which hides those higher level instruction sets. So now I can live migrate virtual machines between different versions of the processor. Now I can't move between Intel and AMD, that's too drastic, but I can move between different generations of the processor in the same family, so within Intel or within AMD, for example. The hot add of scuzzy storage was added, so you can add additional storage to the scuzzy bus on the virtual machines. There was support for things like jumbo frames and virtual machine queues. So virtual machine queues is a feature of the network cards, which effectively create these different buckets on the network card. And then those buckets can be assigned to particular virtual machines, so when traffic is put into that bucket by the network adapter, the Hyper-V switch doesn't have to do as much work to work out, well, where is that traffic destined for. So it just saves processing and speeds things up. NIC teaming was allowed, so Windows didn't have its own native NIC teaming, but if the network card had it, it was allowed to be used with Hyper-V. Microsoft didn't support that. That was still supported by your NIC vendor, but you could now do that. And secondary level address translation was supported. So if your processor could handle the mapping of virtual memory to physical memory, Hyper-V would take advantage of that and again, save some resource. So we carry on through time. And now we get to Service Pack 1 for Windows Server 2008 R2. Now typically I would not include a service pack, but Service Pack 1 was really there expressly for Hyper-V, and it added two features, dynamic memory and remote FX. Now dynamic memory was a huge request, and it was the idea of optimizing the memory of virtual machines. Now before dynamic memory, the way memory effectively had to work, if I look at one of my boxes that's using static, say my SQL box, you define that an amount of memory, and that's it. It has that memory when it starts up, it has it for the time it's running, and it doesn't release it till it stops. But there's a lot of workloads where the memory demand changes over time. Maybe at peak times it needs extra memory, then it doesn't need it anymore. Think of a VDI environment, there's huge fluctuations in the amount of memory I need. So dynamic memory was the memory optimization technique used for Hyper-V, but it was very intelligent. It's not memory over commit, the idea of just giving a VM a huge chunk of memory and kind of hoping it doesn't use it. That doesn't work well with modern operating systems. If a modern operating system sees 2 gigabytes, it's going to go and use 2 gigabytes. It's going to cache things. It's not going to leave memory empty. So dynamic memory actually looks inside the operating system. It sees how memory is being used. Now, if it's being used for cache and it's below a certain buffer value, it's going to leave it alone. But if the processes in that VM are using the memory and it crosses a threshold, then if there's memory available in the host, it's going to inject more memory into that virtual machine. Then when it's not using it anymore, it's going to take it back. Now what I'm going to do is I'm going to take this Windows Server 2008 R2 VM. So the configurations, now I'm going to actually talk about what was here in 2008 R2 was a startup amount of memory and a maximum amount of memory. So I can say it gets 1 to start with, and then it can grow up to 4 gigabytes if it needs to. And that threshold is basically, it says, I want to make sure it always has at least 20% memory available. I don't want to add memory when it's run out. By then performance is degraded, that's a bad thing. So when the amount of available memory drops below 20%, if it's available in the host, it's going to inject more memory. Now if I look right now at this virtual machine, I can see the memory state is okay. And actually, it only needs 384 megabytes. So I'm going to jump over to that virtual machine, and this is it. And what I'm going to do is I'm going to give it some pressure. So I'm going to use a tool called Consume. I'm actually going to use up some physical memory. And I'm going to use that up for 45 seconds. And what's going to happen is this is going to come completely unresponsive. So it's now spawning off these jobs to use up the memory. Now if I look at it here, you'll see the assigned memory has actually gone up already. Memory status, you can see down the bottom here, is saying warning. The demand is going up and up and up. And what it's going to do is inject more memory, you see, into that virtual machine to try and keep up with that demand. It's seeing it's low. It's just going to keep injecting more memory into that virtual machine. So it's adding and adding and adding. So this is dynamic memory, intelligently looking at the usage of the VM and giving it memory actually as it needs it. So that's the key point here. So just going to let that run, so it's getting bigger and bigger. And it's just going to continue growing until really I hit that 45 seconds. And then suddenly it just dropped very, very low. because those processes would have timed out after the 45. But you saw it just injected memory into that virtual machine. And that's huge. I mean, think of a VDI environment. I run it on nearly every single workload, where those memory demands differ over time. It just adds it when it needs it. I get a much higher density on my Hyper-V hosts. And if you think modern operating systems, anything Windows Server 2008 and above, this is the right way to do memory optimization, looking at how it's using memory, rather than just, hey, here's some big blob. Because, for example, if I look at a box over here and I look at Task Manager, I look at my performance, see my memory, available is 620 megs, but I'm using nearly 400 for caching. It doesn't really need it anything for right now, but it sees the memory is available, so it just uses it. You'll actually notice it doesn't even show free anymore. So if I look at my 2008 R2 box and look at Task Manager, one of the things you'll actually see under memory is free. Now that was actually removed in 2012, and the reason is it confused people. People would panic, they saw a very, very small free number. The reality is, you don't care. You're always going to see a small free number because it's using it for caching. What you care about is available, because available is memory that it can use if needed. If a process wanted memory, it can just stop the stuff it was caching and give it to processes. So dynamic memory, huge technology. Very important in terms of density. Remote FX was a technology again related to VDI environments, and it's the concept of viewing rich graphical media. Now, if I connect via, let's say, a Windows 7 box or Windows 8 box to a VDI environment, a virtual desktop, which is where I have client operating systems running in virtual machines. If I try and watch a movie, it's going to play fantastically. The reason is the primitive, i.e. the WMV content, is effectively sent to my local machine, and it asks me to render it myself. It's not actually rendering it on the server. That's a waste of resources. So it's just telling me to render it. Now imagine I connect from an iPad, an Android device. It can't do that multimedia redirection, so I get very, very different performance. Imagine I want to do video conferencing. I want to run Silverlight. I want to run Flash. I want to run a DirectX application. That just will not work because there is no graphical processor in that remote virtual machine. That changed in Service Pack 1. Service Pack 1 allowed me to take a graphics card in my server and virtualize it the same way I virtualize a CPU. And then I can allocate those virtual graphical GPUs to virtual machines. So if I look at the settings of this VM, I've given it a Remote FX 3D video adapter. So this VM thinks it has a GPU. And it's actually this VM I'm running this presentation from. So for example, if I run dxdiag, what we'll actually see is this is a DirectX 11 version. It thinks it has a GPU. And its display type, you see it has an amount of graphical memory. It's using the Remote FX graphics device, a WDDM. And it's enabled for Direct Draw, Direct 3D, AGP texture acceleration. I'm going to get a full graphical fidelity. Now, I'm not going to show it in this video. I have a separate video on this YouTube channel if you're interested. But the way I typically demo with this is I have Lego Batman installed, and I will actually run this, and it runs perfectly. So if you are interested, if you want to see the full capability of that, that's a great way to demo it. So Service Pack 1 added dynamic memory, great graphical capabilities, but still there were scalability challenges. And this is where we now get to Windows Server 2012. And if I think of all the versions of Hyper-V in the past have refined things, improved things a little bit, added some nice features, 2012 is a giant evolutionary leap. This is some of the features added in Windows Server 2012, by no means all of them. But scalability first. 64 virtual CPUs per virtual machine with a terabyte. I mean, that's huge. And when you think 64 virtual CPUs, NUMA becomes a much bigger deal. Non-uniform memory access, the idea that your motherboard has a number of processor sockets on it, and each of those processor sockets is directly connected to certain banks of memory. Now, the best performance is when the process is running on that processor socket are using the memory directly attached. That's called a NUMA node. Well, that NUMA topology is passed through to the virtual machines as well. So if you have NUMA-aware applications, they can make those best practice decisions. But 64 virtual CPUs and a terabyte of memory with NUMA support really for scalability means I can virtualize pretty much anything. There have been studies showing that over 99% of the world's SQL servers could now be virtualized on Windows Server 2012 Hyper-V. Let me actually just show you one of those. So you have a virtual machine, and what I've given it is about 92 gigs of memory and 64 virtual CPUs. So this host I'm running on actually has 64 cores. It's actually got 32 cores, and it's got hyper-threading. And I can see it has 4 NUMA nodes because it has 4 physical processor sockets. Now, that virtual machine, if I connect to it, I can bring up my task manager, performance. I see those same 64 processors available, and I can see the same NUMA nodes available as well. So I have this fantastic level of scalability now available in my virtual machines. And the amazing thing is, it doesn't actually stop. I also have a Linux virtual machine. Now I've given it a lot less memory, but there's no reason I have to. I've also given it 64 virtual CPUs. If I look at this Linux virtual machine, and I bring up Systems Monitor, we see here 64 virtual CPUs available to my Linux VM. And exactly the same way, it's aware of that NUMA topology. Now, I am not a Linux person at all. But here I run this command, and you can see I've got 4 NUMA nodes. It's aware of those 4 NUMA nodes for those processors. So I have this same capability in Windows and Linux. So huge scalability. A new virtual hard disk format, VHDX, which took the limit from 2 terabytes to 64 terabytes. Now, I've never seen an NTFS volume bigger than 14 terabytes. Most are around 3 or 4 terabytes because of check disk considerations. Well, now I can create a 64 terabyte VHDX. This removes the need to have to use pass-through storage. There's also a lot of performance changes made, which means even when a dynamic VHDX is used, it's really giving you bare metal disk performance. Clustering was improved, 64 node clusters, but a big change was the addition of SMB3 support. So prior to Windows Server 2012, the storage for your Hyper-V box had to be block level. It had to be direct attached storage. It had to maybe be in some external enclosure where I had serial attached scuzzy. It had to be on a SAN where I was using Fiber Channel or iSCSI. SMB3 adds file level protocol support. So I can see here I have a virtual machine, my 2008 R21. You'll notice its amount of memory has actually dropped down. So this is one that had all the memory added. It's been reclaimed now by Hyper-V because it's just not using it anymore. So it took it back. But if I look at the settings of this, its storage is actually on an SMB file share. So it's actually using the SMB3 protocol. And there were a lot of changes made to SMB3 to support this, which I'm going to go into detail in later chapters of the book and the videos. But if I just go and look on the file server, if I jump over to Explorer, look at my Hyper-V share, there's the virtual machine storage, and there's the virtual machine's configuration. So it's running completely from an SMB3 file share. Storage migration was added. The idea that I can now move the storage of a virtual machine with no downtime to the virtual machine. So I can move it from a direct attach to an SMB share to a SAN, no downtime whatsoever. So I'm not actually going to perform the move, but very simply, without having to take it down, I could just right click on this. I could say move. Do I want to move the VM or just the storage? So I'll move the storage. Where do I want to move it to? So all to a single location. And I just select that folder. So that could be a different direct attached. It could be that SMB file share. It could be some SAN. Zero downtime. It's not going to shut it down. There's no interruption to the processing of that VM whatsoever. And this opens up some interesting possibilities. So I can now move the storage of a VM with no downtime. I already had live migration. I can now do shared nothing live migration. I can take a VM from any Hyper-V 2012 host and move it to any other Hyper-V 2012 host with no downtime. It could be standalone to standalone, cluster to standalone, standalone to cluster, cluster to cluster. It doesn't matter. You now have complete mobility of your virtual machines. Now, I'm not going to demo that one just for time. I don't want to have to copy the storage over the network. But what I will show is an SMB live migration. So this virtual machine here, that fairly small one, is running on this Hyper-V 01 box. Now, from a networking perspective, and this is something I'm going to cover later on as well, I'm actually got a 10 gig network adapter that's virtualized, and I have a live migration network. So I'll bring up Task Manager, and we just leave this kind of running in the corner. And I find my live migration. There it is. And what I'm going to do is we'll do an SMB. So this isn't within a cluster. Hyper-V 01 and Hyper-V 02 are not clustered. They're shared nothing other than this SMB file share, which is where this VM is running on. I'm going to say I want to move it. Just move that up for the time being. I want to move the VM. I want to move it to a different box. And again, this would work exactly the same way with shared nothing. This effectively what this is kind of doing is that they can both access the SMB, so they don't have to copy the storage. I just say move only the VM, so I'm not going to copy the storage. Next, and I'm going to say finish. And what's going to happen is here's that connection to the VM. I could run Internet Explorer. I could be doing things in here, maybe go to Bing or something. So just use it. Nope. There we go. And what I'm going to do now is I'm going to say, sure, perform that move, finish. And I'll see a bump in traffic. It's going to shoot up really high. Notice it's now sending at 3.2 gigs and it's finished. The VM is gone. It's now running on the other box. It's been running for 8 seconds. I didn't get disconnected. There was no interruption to anything I was doing. That's it. And again, exactly the same thing would work with a shared nothing. It would just take a bit longer because it has to copy the storage as well. But that's now just a native feature of the operating system. And again, because I've got the 10 gig network, it's very hard to see anything actually happening. But there was that blip. It went up to about 3 gigs. And it only had to copy 512 megs of memory. So very, very fast and zero interaction. We have Hyper-V Replica. So Hyper-V Replica is the idea of disaster recovery. I have a group of virtual machines and I need to protect them from natural disasters, building failures, meteorites hitting the building. Doesn't matter. But maybe I don't have SAN level replication. I can't do a synchronous replication between buildings. Or maybe these are tier 2 apps that don't make sense to run on those technologies. Hyper-V Replica effectively lets me take virtual machines, and I've got one over here, my remote desktop gateway, and I've got this configured to replicate. Every 5 minutes, the changes to the storage of this virtual machine, and I can go and look at that virtual machine, and I can see its virtual hard drives, and there it is. And essentially what would happen as well is there's changes to that VM are logged, and those changes are then actually shipped over to the replica side and then ran into that replica. So here's a replica, And one of the nice things I can do is every 5 minutes it's sending those changes. But one of the great things you can do is your disaster recovery site probably has a different IP configuration. So in these settings, you can actually go and specify an alternate IP configuration that will get injected in the case of a failure. And I can do a planned failure, an unplanned failover, a test failure. And I can say, well, tell you what, let's do replicas every 4 hours, do an app consistent replica. So I have all of those capabilities. So my replication is paused right here. So I can actually say, look, resume my replication. So it's then going ahead and replicating those changes. And then what I would see is it would start catching up, and I'll start seeing a Hyper-V replica log file created, which is where it's storing those 5 minutes of changes. So it's resynchronizing. It's saying resynchronization is required because I actually just deleted all of these and then I re-imported them in. So I'm going to have to do a resynchronize. Virtual fiber channel is added. So this lets me actually take my fiber channel connections in my SAN and then actually map those to virtual machines. This now lets virtual machines directly access my fiber channel SAN. That's useful for guest level clustering scenarios. So if I want to create a cluster within virtual machines and they want to access shared storage, in the past I would have to use scuzzy. Well, now with this virtual fiber channel, I can actually let them use fiber channel storage as well. There's network virtualization. The idea that I can create a red network and a blue network, a Coke and a Pepsi network, and they're completely isolated from one another. They use their own IP schemes. So if you're a hoster, for example, or just because you have different business units and you want to keep them separate, maybe I'm tired of using VLANs. There's obviously a pretty big restriction. I can have basically 4,000 VLANs. Or maybe I'm running out. A lot of switches will actually restrict you to 1,000. With network virtualization, it's all software-defined networking. There's really no restrictions. Of course, we're going to go into this in a lot of detail later on. Dynamic VMQ and SOIOV support was added for the highest levels of networking performance. SOIOV lets the network cards that support SOIOV really give virtual functions. These act as like virtual network adapters that are then mapped directly to virtual machines, effectively bypassing the switch. So this gives you the highest levels of network performance, pretty much no latency, but it means I can't take advantage of any features in the switch. Dynamic VMQ takes those virtual machine queues and moves them between VMs basically on who needs it the most. The Hyper-V switch became extensible. So the idea here that I can actually add extensions into the Hyper-V switch. If I look at my switch manager, I can actually go and pick a switch. I can just add extensions into here. So Cisco Nexus 1000V, for example, is available. I can now manage my physical and virtual networks with the one tool. SFlow, Inmon, Windows filtering platform and NDist APIs are supported. So very easy to actually extend the capabilities of the Hyper-V switch through third parties now. Dynamic memory was improved, and you kind of saw this already. So if I go back to my 2008 R2 virtual machine, which is actually now running on this other box, if I look at the settings, we actually see the memory started with a gig. It could grow to 4, but now it added the ability to have a minimum. And this is actually what's being used right now. You can see here, it's actually only using, 546. And the logic here is, well, maybe when the VM starts, it has to see at least 1 gigabyte or 2 gigabytes. Then once it's up and running, it just doesn't need it anymore. So this allows Hyper-V to take memory back, even below the amount it was given when it started up. So that was a big change in 2012 to memory. Resource metering is available. So resource metering effectively lets me track the usage of a virtual machine. So here I'm on my Hyper-V host, and what I'm going to do is I'm actually just going to get my VM, and I'm going to enable VM resource metering. So what this is now doing is it's saying, okay, well, let's check what's actually going on in certain aspects of this virtual machine. And then I can just measure it. So this is going to give me certain metrics. I'm going to format that as a list. So I can see, for example, memory detail. I can see processor cycles. So this isn't percentage-wise. That would be kind of useless if I moved VMs between different boxes with different capabilities. So this is cycles, hertz, effectively. I can see total amount of disk space used, memory information, just basic metering. But this is very useful if I want to be able to charge or show back, for example. And I already showed some of the great Linux support. And really, all of the features available work with Linux. Live migration, those SMB, Hyper-V replica works, and with the latest Linux integration services, timeline of 2012 R2, I can inject the IP in that failover. So really, all of these features work, with a few exceptions. Dynamic memory didn't work. Live backup didn't work with Linux. But these are things actually addressed in the future. So when we get to 2012 R2. And 2012 R2 adds a huge amount of other things. Now, one of the big first things is this UEFI Generation 2 virtual machine. Now, if I look at a standard virtual machine, actually, I'm going to put 2012 one. So let me fire up Device Manager. And what do we see? We have an IDE controller. This is an emulated IDE controller. I see a bunch of system devices, ISA bridges, Pentium 2 processor to PCI bridges, system speakers, system timers, real stuff. I see PS2 keyboards and mice. And the reason we have this is virtualization, when it was first really mainstream, was not natively understood by the operating system. You had to install integration services, but you had to have all this emulated stuff so you could install the operating system. It had to see an IDE controller. I might need a legacy network adapter to boot over the network. Well, times have changed. Modern operating systems, Windows, Linux, are natively virtualization aware. So really, I don't need all that junk anymore. So if I now have a Generation 2 virtual machine. Now I have the choice. When I create a VM, I pick is it Gen 1 or Gen 2. But if I fire up that device manager on a Gen 2, it's very different. It's cleaner looking. If I fire up again on the old one, I see more stuff. This is the Gen 1. It's the Gen 2. I don't have all those PCI, Pentium 2, IDE things. I don't have an IDE controller at all. I don't need it. I now boot from the virtual synthetic SCSI bus. I don't require PS2 keyboards and mice. I don't have common LPT ports. Although you can still, if you really need it, I can add a COM port maybe for remote debugging purposes through PowerShell. But it's really removed all of that synthetic stuff. If I run msinfo, if I run it correctly, I'll see it's a UEFI. Whereas a Gen 1, if I run msinfo 32, is BIOS based. It's going to be legacy. Now, Generation 2 VMs are something you're going to want to use for Windows Server 2012 and above. You can't use it for older operating systems. And they're going to install quicker because it's UEFI and there's not all this there's not all this emulated hardware. It's going to boot quicker, but once it's up and running, it's not really going to make a huge difference at that point. So it's not something where you're going to be desperate to try and convert all your Gen 1 to Gen 2 virtual machines. In fact, you can't really. There's fundamental differences between the deployment of a BIOS-based OS and a UEFI-based OS. UEFI boots from a FAT32 system partition. It's just really not compatible. If you really were desperate, you'd have to capture the operating system to like a WIM file and then redeploy it. But certainly for your newer operating system deployments, it would be great to sort of start leveraging the Gen 2 virtual machines because you do away with all of that emulated hardware. I now boot from my virtual SCSI. I can now boot from the synthetic network adapter. I don't have to add a legacy network. In fact, they're not even available. if I actually go and look at the settings of a Gen 2, and I look at my hardware, I don't have the option for a legacy network adapter. I don't have the option, I don't see IDE controllers. It's a much, much cleaner environment now because I don't have all that non-virtualization stuff. I don't need it. This is now a natively virtualization aware operating system. There's now the ability to dynamically resize VHD files on the SCSI bus. So I can now make them bigger or even smaller. I can share a VHDX file now between multiple virtual machines if it's hosted on cluster shared volume or a scale out file server. So those SMB3 file servers, that's actually a file cluster. So this is great for those guest clustering scenarios. So in the past, I had to use scuzzy or Fiber Channel. Well, now I don't. Now I can just create a VHDX file on that CSV or scale out file server and connect it to multiple VMs at the same time. And they will see it as shared SAS. They will use that as shared storage. There was improvements to storage metering in Windows Server 2012. So if I jump back to my box again, so if I open up my PowerShell, and I actually got an example over here. So if I go back to my Measure VM, I actually see a few extra things. So you remember before it showed me total disk under 2012? Well, now it's also showing me information about the performance of the disk. So read, write, latency, IOP information. It's giving me more details about actually the storage as well. So it's giving me better performance data. Another nice thing I can actually do as well now is under my storage, if I go to my advanced configuration options, I can enable QoS. I can limit it, so I can say maximum, so it cannot exceed a certain amount of IOPS. I can also say, well, if it drops below this value, alert me. This is where you can enable that virtual hard disk to be shared. So great new storage capabilities. There's the option to do live migration, compression, or even use SMB. So if I look at a box now, I'm going to look at my Hyper-V settings and live migration. If I enable it, what you can actually now do as part of your live migration is if I go to my advanced features, I can now, by default, see it's using compression. So it's going to use CPU cycles to compress the memory to reduce the amount of network bandwidth and speed up the migration. Now it is using more CPU cycles both on the sender to compress it and the receiver to decompress it. So if I have a fantastic network, maybe I don't want to use compression. If I'm, in my case, my 10 gig, I'm probably fine without it and I don't want to use the CPU cycles. But if you are finding bandwidth is a limiting factor, it's going to use compression by default. If you have the newest types of network adapters that support remote direct memory access, RDMA, I can say use SMB, and then it will use SMB direct and really allow the network adapters to directly communicate to the memory, making it the fastest live migration, and it doesn't use any CPU cycles. It doesn't compress it. It doesn't need to. It's giving you this lightning fast live migration now that's really going to be much quicker than anything even with compression. So you have more capabilities with live migration. Hyper-V Replica has got more granular. So in 2012, it was a 5-minute replication frequency, and I could not change that. In 2012 R2, I can say 30 seconds, 5 minutes, or 15 minutes. Additionally, I can add a replica of a replica. So if I already had Hyper-V Replica running, and maybe I wanted another location, another replica, I can extend Hyper-V Replication to another VM copy. Network virtualization. Actually, now it's simpler. There's some additional features, and a gateway is now included. So this enables you to connect different virtual networks together, or even connect to the physical network fabric. Snapshots have been renamed to checkpoints. This makes it a bit more consistent because I think there was a lot of confusions between VSS, like backup snapshots, and snapshots, i.e. a point-in-time view of a VM. So they're now checkpoints, and you can do that while the VM is actually running. So it's almost like cloning. So if I have a VM running, I can actually just say I want to checkpoint it now. So it's not going to stop it, it just goes and creates a clone. If I had checkpoints, I can actually go and export. So you can see I've got the export option as well. I can export checkpoints without shutting down the VM. So a lot more functionality around those taking the copies, maybe in a test dev scenario, to do that. Virtual receive side scaling. So if in the past, VM queue and receive side scaling were mutually exclusive. Receive side scaling allows a stream of network connectivity coming in to be spread over multiple processor cores. Very important if you've got a 10 gig network. With virtual receive side scaling, I can effectively now use VMQ and RSS together. It's going to do a software RSS to really maximize the performance. Automatic VM activation. In 2012 R2, if I'm running Windows Server 2012 R2 Data Center Hyper-V and it's activated, any Windows Server 2012 R2 VM is just activated automatically. Nothing I need to do. It's not using KMS. It's not using Active Directory based activation. It will just automatically activate because the host is activated. This is a very nice feature. And then even better Linux support. Dynamic memory now works in Linux. There's now a live file backup feature in Linux. The Hyper-V replica IP injection works in Linux. So really just this fantastic set of features. And so this is where we are right now. And if you look at Hyper-V and you look at everyone else, I mean, Hyper-V has this fantastic scalability. No one even comes close to 64 terabyte virtual hard disk. They still have to use pass-through storage on other hypervisors. Fantastic feature set, great inbox disaster recovery, great network virtualization. And again, then you layer System Center on top of this, you have a fantastic manageability. And of course, great compatibility with Windows Azure. So this was my pretty quick, less than 45-minute overview of just where we've really got to with Hyper-V right now. And this does supplement that first chapter of the Mastering Hyper-V 2012 R2 book. Thank you very much.